Now we're going to be dealing with slope, and slope is just one aspect of how we describe a line. We already talked about how you graph lines for like y equals 2x or something like that, but now we're going to talk about how that slope works and how that interacts with the points on the line. And slope is just a ratio that describes the steepness of a line. And the rise is the vertical change, and the run is the horizontal change. So if we have a point here, the horizontal change is going to be 1, 2, 3, and that's always positive. The rise is going to be whether it's going up and down from left to right. In this case here, this is a negative slope because it's going down from left to right for the x-coordinate. In this one case here, it's going to be a positive slope because it's going up from left to right. So the y value increases here, the y value decreases here. So if you look here, what it is, the slope as an overall concept is, it's the ratio of the rise over the run. And here, each time it goes down 1, it goes over 1. Down 1, over 1, down 1, over 1. So it's -3 is what they chose this point to be, -3 over 3. And so that's going to be a -1 slope. So actually this equation here is going to be y is equal to -x. That's just the value there of that one right there. Now over here, we count again. We see, well, it goes up 1, 2, 3, 4. So that's going to be our bottom, our x, our change, our run, our change in the x value. Up here is going to be the change in the y value. And it's going up by 1. So this, actually this one right here, it's going to be, this equation is going to be 1, 2, 3. It's going to be y is equal to 1/4 x, I have to draw this down here, plus 3. So that's going to be the whole equation because it starts at 3 and then goes up by 1/4. And don't worry about this yet. We'll talk about this more. We'll get back to the cockroaches, if you remember that, and that wonderful little program there. So if we see here, finding the slope of each line here, and these are examples, what we need to do is we need to find a point. So there's a point that's easy to recognize, and there's a point that's easy to recognize. For each of these, we need to find points where they're clearly where they are crossing the intersection. And so some of these are a little bit harder to see, and some of them are not 100% precise. But we're gonna say that for our purposes here, that this one right here is going to be a point 2. And for here, we got a point right here and a point right here. Now all we do is count. We just say to ourselves, well, how much is the rise over the run? When we do that, all we're doing is we're saying, okay, so how much does it go down each time? I'm just changing the line format a little bit here to make it a little bit easier to read when I write. So I count it. I just say, okay, well, it goes down 1, 2. It's a negative slope. That's the first thing you want to determine. Is it negative or positive? It's a negative slope. So now it goes down 1, 2. So that's the rise. And then it goes over 1. So the slope is just going to be -2. That's just what the slope is going to be, -2. Now over here, for this one here, we do the same thing. All we're going to do is we're going to count. Well, we go over 1, 2, 3 in the x. So is it going to be a positive or a negative slope to begin with? It's going to be a positive slope. And the run is 3. It doesn't matter which one you choose. If it's rise or run, you choose first. But just make sure to cover them both. And then how far does it go up when it gets there? It goes up 1, 2, 3, 4, 5. So in this case here, this line would be would have a slope of positive 5 over 3. And this one here, again, it's a positive slope because it's going up from left to right. Now I count 1, 2, 3, 4. So 4 on the bottom because that's the change in x, and 1 on the top because that's the change in y. That's all it is. Now, in this case here, for this next one, what we're going to do is we're going to plot a point and then figure out what the line looks like based on the slope. So if we plot a point right here, we go over point P here, 1, 3. So we got a point right here. And now if we have a slope of 1/2, that means each time we go over 2, we go up 1. Over 2, up 1. Over 2, up 1. And then we could do the same here, over 2, down 1, when we're heading in the negative x direction, or the lower x, when we're becoming more negative for x. And then we got a nice line right here that you can see pretty clearly, I think, but we'll go ahead and we'll try and draw it, so that's kind of our line. Remember, a line always goes on forever, so you need to go ahead and indicate that by that. And if I have this point here, 2, 2, and a slope of negative 2, then that means each time it goes over 1, it goes down 2. Over 1, down 2. Over 1, down 2. And in this case here, when we go over 1 the other way, you go up 2 because you're starting off, because it's going downhill. It's just easier to think of this one. It's a negative slope. It's going downhill. Now, one of the things that one of the last times I remember clearly, the problem with slope in my real life was I went on a skateboard ramp a few years ago, and I was pretty good at this one here. I was fine with it. Then I decided to go down this one here. Now this one here, I screwed up on, and I fell over, and let's just put it this way, it was not pleasant. So I kind of haven't been out very much since then. But this one here, much tougher, much higher slope than this one right here. Or in this case here, it's a higher slope this way. It's a steeper line than this one here. By the way, my main problem with these guys here, with this slope here, this guy right here, and this guy right here, what do you see that's missing? This is a skateboard ramp, and they're riding their bikes and their rollerblades. Gotta say, that is not the way I would do it. And we are done with our lesson today on slope, and hopefully you remember that about the guys on the skateboard ramp.